Okay, we're going to look at a new lesson today, which is called completing the square. Okay, so just quick definition to get going. Completing the square is a method of partly factorising a trinomial expression that cannot be fully factorised. Okay, so remember that factorising is the act of putting an algebraic expression back into brackets. Okay, now, the examples we've seen have been, simple examples we've been seeing has been ones like that. X squared plus 8x plus 15. So you would then find a combination, two numbers that multiply together give 15 and add together give 8. And in this case, those two numbers would be 5 and 3. So x plus 5 and x plus 3. Now we haven't looked though at questions like this. So this time we're looking for numbers that multiply together to give 11 and add together to give 6. It just turns out that there's not a combination that's going to work there. So numbers that multiply together give 11 or 1 and 11, and that's it. That adds together to give 12, so we're stuck for fully factorising this one. Okay, so again, if we think about x squared plus 7x plus 12, two numbers that multiply together to give 12, add together to give 7, that's easy, that's 3 and 4, x plus 3, x plus 4. Two numbers that multiply give 15, add together to give 5, that's easy, that's 5 and 3. But two numbers that multiply give 11, add together to give 6, there is no combination. Now in that case, what we need to have a look at is something called completing the square, and that's the subject of this lesson that I'm about to deliver just now. Okay, so first of all, let's kind of backtrack and see if we can establish a well thought out routine for how to do these questions. Okay, so let's go back to some work that we already know about. And let's say we had x squared plus 4x plus 4 and that we're going to factorise that. Okay, so x squared plus 4x plus 4, two numbers that multiply to give 4, add together to give 4. Okay, we can find the combination there. It's 2 and 2. 2 times 2 is 4 and 2 plus 2 is 4. Okay, so that could be written as x plus 2 times x plus 2. Okay, now remember that if you've got a bracket beside another bracket, those brackets are multiplying. And also remember that 5 times 5, another way of writing that is 5 squared. T times t can be written as t squared. Well, x plus 2 times x plus 2 could be written as x plus 2 all squared. Okay, so x squared plus 4x plus 4 now can be written as x plus 2 all squared. Let's try another example. X squared plus 6x plus 9. Two numbers that multiply give 9, add together give 6. That's 3 and 3. 3 times 3 is 9, 3 plus 3 is 6. And that to x plus 3 times x plus 3 could be written as x plus 3 all squared. So that can be written as that. Okay, x squared plus 10x plus 25. Two numbers that multiply give 25, add together give 10. That's 5 and 5. 5 times 5 is 25. 5 plus 5 is 10. X plus 5 bracket x plus 5 can be written as x plus 5 all squared. Okay, another example. X squared plus 16x plus 64. Two numbers that multiply give 64, add together give 16 is 8 and 8. 8 times 8 is 64 and 8 plus 8 is 16, and that can be written as x plus 8 all squared. Okay, now let's see if we can just establish a routine and a pattern here. Right, x squared plus 4x plus 4 ends up x plus 2 all squared, so we can see that that 4 goes down to 2 and you create a square bracket. Okay, x squared plus 6x plus 9, the 6 goes down to 3 and you create a square bracket. X squared plus 10x plus 25, the 10 goes down to 5 and you create a square bracket. X squared plus 16x plus 64, the 16 goes down to 8 and you create a square bracket. 4 down to 2, 6 down to 3, 10 down to 5, 16 down to 8, and we create a squared bracket. Okay, so what's the pattern we can see emerge there? Well, that number of 4 half down to 2, 6 half down to 3, 10 half down to 5, and 16 half down to 8, and we created a squared bracket each time. Okay, so let's imagine we were asked to factorise x squared plus 4x plus 9. Okay, so initially we could think, right, well, let's find two numbers that multiply give 9 and add together give 4. The two numbers that multiply give 9 are 1 and 9 and 3 and 3, but both of them will not work. Okay, so in this case we're going to look at partly factorising by completing the square. Now what we do know is to get x squared plus 4x, to get those two terms definitely come out of x plus 2 all squared because we've already seen that happen. So we know that that is definitely going to be part of our answer. How do we know? Well, x squared plus 4x plus 4, we did factorise that to get x plus 2 all squared. So to get those first two terms, that will definitely come from x plus 2 all squared. However, that squared bracket will also produce this term of 4, which is not in our question. We don't want that. But that square bracket will definitely produce that term. But if we don't want it, we should eliminate it by taking it away. We do, however, want the plus 9, so we need to add that on. And then we just tidy it up. Be careful, minus 4 plus 9, minus 4 degrees outside, gets 9 degrees warmer, brings us up to plus 5x plus 2 all squared plus 5. Now, you'll find this quite easy once we establish a routine and get into several examples, so just bear with it just now. That's example 1, so let's just go over it again. Okay, x squared plus 4x plus 9. Okay, we know that x squared plus 4x plus 4 came from x plus 2 all squared. Well, we know that the first two terms, which we've got there, will definitely come out of x plus 2 all squared. But the other thing that comes out of x plus 2 all squared is plus 4. That's not part of our equation, so we eliminate it, take it away. But what is part of our equation is plus 9. You need to put that on. Minus 4 plus 9 is plus 5. Final answer, x plus 2 all squared plus 5. So you can see that things partly factorised because we managed to get this bit in brackets, but not the plus 5 here. Let's try another example. Example 2. Okay, x squared plus 6x plus 11. Okay, now we've seen from x squared plus 6x plus 9 that came from x plus 3 all squared. So we'll definitely get the x squared plus 6x from that squared bracket. However, we've got plus 11 at the end, not plus 9. We don't want that plus 9, so we eliminate it, but we still need to add on 11, which gives us x plus 3 all squared plus 2. Okay, we're going to try a third example, and then we're going to establish the steps that will take us to the correct answer every time with these questions. So let's take down an example 3. Okay, example 3, x squared plus 8x plus 17. Okay, we're going to complete the square. So two numbers that multiply together to give 17, add together to give 8. Okay, so there's nothing that exists there, so we need to complete the square, just the same as two numbers that multiply to 11 and add together to give 6, there was nothing there. Okay, now x squared plus 8x, we know that comes from the squared bracket x plus 4, x plus 4 all squared. Okay, however, that squared bracket would also have a plus 16 on the end. We can see that our question doesn't have plus 16, it's got a plus 17. But the plus 16 will come out, so what do we need to do? We need to eliminate it as soon as it comes out, take it away, but then add on the 17, which will give us a final answer of x plus 4 all squared plus 1 minus 16 plus 17 is plus 1. Okay, so let's establish this routine with example 4. We're going to complete the square with x squared plus 6x plus 13. Okay, so there's no combination of numbers that multiply give 13, add together give 6, so the alternative is to complete the square, that's partly factorising. So getting some of the expression in brackets, but some of it not quite. Okay, our first move is we half the 6 down to 3. Create a squared bracket. Now, from the squared bracket, 9 will come out of this squared bracket. So remember that two numbers that multiply give 9, add together give 6 is 3 and 3, x plus 3, x plus 3. That can now be written as x plus 3 all squared. So x plus 3 all squared will also give me plus 9 at the end. Now, as we can see, we don't want that result, so we immediately take it away, but we need to include the 13, so we add that on. Minus 9 plus 13, so if it's minus 9 degrees, it gets 13 degrees warmer. Take your time, that will give you plus 4x plus 3 all squared plus 4. Okay, now let's think about a quick routine with these questions. You half the 6 down to a 3, you create a squared bracket. 3 squared is 9, so you get rid of 9, but then you need to put on whatever was on the end, which was plus 13. Okay, so let's go over that again. Half the 6 down to 3, half the 6 down to 3, create a squared bracket. 3 squared is 9, get rid of it, but I still need to add on 13. Final answer, x plus 3 all squared plus 4. Okay, so the routine is you half the 6 down to 3, create a squared bracket. 3 squared is 9, get rid of it, but then I need to add on 13. Let's try an example 5 and establish a few examples at pace here. So x squared plus 4x plus 15, we're going to complete the square. Okay, our first move is we're going to half the 4 down to a 2 and create a square bracket. And then it's 2 squared is 4, and we're going to get rid of it, but we still need to add on 15. And then minus 4 plus 15, take your time, that's plus 11. So let's just follow that routine a second time. Okay, so half the 4 down to 2, create a squared bracket. 2 squared is 4, get rid of it, and I still need to include 15. Final answer, x plus 2 all squared plus 15. Let's take down example 6. Okay, x squared plus 10x plus 31. Okay, we're going to half the 10 down to 5, create a squared bracket. 5 squared is 25, get rid of it, add on 31. Be careful, it's minus 25 degrees outside, it gets 31 degrees warmer. Take your time with that, and that will give me x plus 5 all squared plus 6. Okay, so let's just look at the routine in action with two examples side by side. 2 squared is 4, get rid of 4, and I still need to add on 15, half the 4 down to 2, 2 squared is 4, get rid of it, and I still need to include 15. Half the 10 down to 5, create a squared bracket. 5 squared is 25, get rid of it, and then I still need to include plus 31. Okay, let's try another couple of examples. Example 7, x squared plus 12x minus 5. Okay, half the 12 down to 6, create a squared bracket. 6 squared is 36, I need to get rid of it, it's taken away, and I still need to include on minus 5 this time, so it's x plus 6 all squared. Just be careful, minus 36 minus 5, you're down at minus 36, you travel down another 5, takes you down to minus 41. So let's just go over that one again. Half the 12 down to 6, create a squared bracket. 6 squared is 36, get rid of it, but you then still need to include minus 5 and then you tidy it up. Okay, example 8, x squared plus 2x minus 11, half the 2 down to a 1, create a squared bracket, 1 squared is 1, get rid of it, and I still need to take away 11, x plus 1 whole squared minus 12, example 9. Okay, example 9, y squared plus 14y minus 11. Okay, the numbers is going to be a wee bit bigger here, but follow the same kind of rules. Half the 14 down to 7, create a square bracket, 7 squared is 49, but I need to get rid of that, and also include the minus 11. Okay, so it's y plus 7 all squared. Be careful, take your time, minus 49, minus 11, I'm down at minus 49, travel down another 11, takes me down to minus 60. So half the 14 down to 7, 7 squared is 49, get rid of 49, and I still need to include minus 11, y plus 7 all squared minus 60. Let's take down example 10. Okay, t squared plus 8t minus 13, half the 8 down to 4 and create a squared bracket, t plus 4 all squared, 4 squared is 16, get rid of it, and I still need to take away 13. So it's going to be t plus 4 all squared minus 29. Okay, example 11. Okay, now just as an aside, 4 squared is 16, but minus 4 squared is also 16. Remember that if you square a negative number, you get a positive result. Okay, so what about x squared minus 8x plus 11? Okay, so this time we're going to half not 8 but minus 8 down to minus 4. Minus 4 squared is still 16 because minus 4 times minus 4 is 16, but we still need to get rid of that 16 and then add on 11. Okay, let's take our time. Minus 16 plus 11 is minus 5x, minus 4 all squared minus 5, example 12. X squared minus 10x plus 7. Okay, we're halving down not 10 but minus 10 down to minus 5 and creating a square bracket. 5 squared is 25, we get rid of it, but minus 5 squared is also 25 and we still need to get rid of it. And then include the plus 7. Minus 25 plus 7 is minus 18. Okay, let's try one final example. T squared minus 20t minus 210. Okay, half the minus 20 down to minus 10, create a square bracket. 10 squared is 100, we would get rid of it. Minus 10 squared is also 100, we still need to get rid of it. And include the minus 210. Okay, let's tidy that up. Minus 100 minus 210 is minus 310. Final answer, minus 10 all squared minus 310.